is Darshan, and I'll be going through our final project for the course Data Center Scale Computing, which is titled Study Group Manager. Along with me, I have Ruben and Vignesh. So we'll go through the important topics here in the presentation. So the basic idea is to create a study group formation application where students with similar academic interests can join, discuss about a particular topic, and basically have a worthwhile experience using the application. So we provide real-time chat to coordinate between themselves. We provide email notifications for group creation and upcoming events, and we also provide friend management functionality as well. So here are the software and the hardware components: React.js, Node.js, front and backend, RabbitMQ for profile picture processing, and then email notification sending, basically all the asynchronous tasks. Redis to help with socket management that is used in the real-time chat, and then Terraform to basically bring up the entire infrastructure. And yeah, the APIs, we provide the Zoom links for online meetings, and also databases, Firestore, Google Cloud Storage. Hardware are these all. And to build the infrastructure, have a service account with proper permissions and roles. And then the Terraform is going to basically use the service account to bring up your entire infrastructure. And then you deploy the front and back end. The Redis, the worker containers on your GKE cluster that's been created by Terraform, and then configure your DBs. So this is our architecture diagram. We have the front end service connects with the load balancer of the GKE, and the client can connect to the front end. The front end is going to have constant communication with the back end microservices. There are two. The chat functionality service is used for the real-time chat application that uses Socket IO. So here we use session affinity so that a client once connected to a pod will stay connected until he logs out. This is to make sure that there is a particular channel that always stays open between the user and the backend service, and this is a normal REST API. So we have Redis. Redis is used by the chat functionality service. So the chat functionality, if it couldn't find the particular recipient socket information, then it is going to publish information to the Redis, and every other parts in the chat functionality service is going to get the message and will be sending or forwarding the message through the channel if they contain the socket information of the recipient. So we have email worker, profile picture worker, and then we have an VM instance with the RabbitMQ. RabbitMQ is going to queue all the asynchronous tasks. These are going to perform the functions. Uh, yeah, and Google Cloud Storage to store all the profile pictures. The profile picture worker, after compressing the profile picture, is going to put on the Google Cloud Storage, which will be used to view the profile picture in our front-end application. Email is going to send all the emails. Firestore is our main primary database. Yeah, the general workflow, signups, creates a group, and then people join group and coordinate between themselves. Some of the important interactions which we'll be going through in our working. Debugging, we have added detailed logs in backend, and also we have RabbitMQ, which helps us trace the execution. We also have Google Cloud's log monitoring, which gives information on the container logs um, after it's deployed on GKE. And then to deploy and test the containers locally, we use the Minikube cluster, and we also performed integration testing between the front end and the back end using Postman and also using other databases. So as far as the workload capacity, the entire system can is highly scalable since it's all containers that is deployed on GKE. The WebSocket based chat system is also made scalable using Redis. And yeah, it has RabbitMQ, so asynchronous tasks will also not induce any slowness in the system. So the potential bottlenecks. So the major thought within our group is that we could have implemented a pipeline so that we don't have to deploy all these services manually on the cluster that we have created using Terraform. And then, yeah, if there are a lot of users, then it's going to give some strain on the chat microservice that we have. Welcome to the demo. So we have all the infrastructure deployed using Terraform, and then we deploy the containers here. So we have all the containers running, and we have the Rabbit instance running, the buckets, the databases, and this is what I use to see the container information if they are running properly within the GKE. So this is the Terraform where we store the Google credentials and make sure it's safe. And yeah, this is the different collections that we have within the database. One more thing that's going to happen. So we'll have this sign up email being sent to this email address once we click on submit. And then the other pipeline that I explained, where the profile picture is going to be compressed and then stored back to the client's collection. So we have our profile picture URL being generated after it was compressed, and here is the image, and we are also now logged in into the website. So we can create a group and quickly join a group, and we'll test the real-time chat application next. So now we have the setup ready. So we have created a group called live demo, and we will try to join the group. And yeah, now we can view the group and basically chat within ourselves. Yeah, so here, so we got it here. And we also get a notification on the top saying group message, what group it is, and the message. So as you can see, this uses WebSockets to do this. And in the background, there's an REST API call that is being made to save these messages, but these two are not polling the server for any message. The server is directly sending them these messages that are to be updated. Yeah, so and I'll also show you how the consumers are consuming the queues. So yeah, here we have a consumer that consumes email and it is sending the sign up emails, and it's for Ganesha as well. And then we have another consumer here for profile photo, and this is the photo that it's retrieving, and then yeah, it is compressing and then uploading the compressed image and then updating the user data in the Firestore to point to this link. Yeah, so that's it with our project demo. Thank you so much.